Okay.
Let's begin. So we're going to finish up that section that has linear approximation and marginal functions by talking about marginal functions. This is actually, the context here is economics, so it's application of derivatives in economics. So what is a marginal function? Okay, so let's look at a motivating example. Okay, suppose you have a cost function. Suppose you have a function c of x, which is the cost to produce x items of some product. Right? If you look at the derivative, what's going to happen is that, well, by definition, this is the limit as h approaches 0 of c of x plus h minus c of x all over h, which basically means one way in which you can look at this is that the derivative, the left side and the right side, the closer h gets to 0, the closer those two guys get together. So you can in fact think of this as c prime is approximately this ratio when h is, let's say, small, as in close to 0. The closer it gets to 0, the better the approximation gets, right? That's kind of how we develop the derivative. So we start with the slope of the secant line, and then we kind of let the distance between x and x plus h go to 0, and the closer we got to it, the closer the secant line got to becoming the tangent line. So the idea is, if we just pretend h is super close to 0, the closer the better, I can just say, this is roughly that. They're pretty much the same thing. We get the equality when we take the limit. But I can look at the derivative as an approximation of this kind of quantity. Now, here's, in economics context, h equals 1 specifically is often considered very small, close to 0. Right? So I'm some major manufacturer. I'm making thousands of products, right? One product isn't a big deal. Might as well be 0. Like if I'm producing 50,000 things, what's one thing against 50,000 things? 1 is pretty much the closest you would get to 0, right? What's the smallest amount of things we're going to produce? One thing. No one's going to produce half a product or anything like that. So 1 is pretty much as close to 0 as you can get without being 0 itself from a production or standpoint. So this would mean that my derivative, I can think of it as approximately being equal to, where I'm going to now plug in h equals 1 into the, right here, as c of x plus 1 minus c of x. Of course all over 1, but that's just itself. And this is the main equation that sparked this whole marginal analysis, as it's called. Right? So the analysis of marginal functions. And I'll tell you about what a marginal function is pretty soon. But we're kind of building up to it. So you have a function that measures cost. The derivative by definition is this, which basically means the closer h is to 0, the left side and the right side start to get very close together. If I think of h equals 1 as being close to 0, I get this equation. Now, question to the class. What does the right side represent? If you were to tell me, like in words or as an an idea. If you see c of x plus 1 minus c of x, what does that mean to you? What is that talking about? How do you interpret that expression? C of x plus 1 minus c of x. What does that mean to you? I mean, what is c of x plus 1? How do you interpret this part? What is that? Remember, c is just a cost function. Cost to produce x items. What is c of x plus 1? What would you say? Yeah?
Cost to produce one extra item in the amount that you have.
So this is the cost to produce one more than x, right? X plus 1 items. And this is, of course, the cost to produce x items. And then we took the difference. So if I look at c of x plus 1 minus c of x, that is interpreted as, what were you kind of saying now, put these together?
The cost to produce one item.
Cost to produce what?
One, yeah. Cost to produce one.
One specifically? Like any one item? It's a cost to produce one more item after x have been produced. And because I'm subtracting the cost to produce the first x, I can even think of this as the additional cost, to be more specific. Right? So c of x tells me how much it costs me to make x items. C of x plus 1 tells me how much it costs to make x plus 1 items. If I take the difference, it just tells me, okay, if I've made x of them, how much would it take me to make one more than x, right? What additional cost would that incur? This difference is going to tell you what that additional cost is. So, i.e., in economics terms, we can say that c of x plus 1 is the cost to produce one more item at the margins, as you would say, right? So we're at the current level of production, right? We're here now where we're producing X items. If we're to push the margin a little further, if we're to go one more, what's gonna happen to our costs, right? If you want to answer that question, you're gonna find this difference. That's how you would figure out what happens to the cost if we push the margins a little further. Go a little bit farther than where we are right now. Just expand our margins a little bit, what's gonna happen, right? And on top of that, and since our c prime of x, notice what we can have for c prime. It is approximately equal to that difference. C prime of x approximates this. It is therefore called the marginal cost function. And I'm going to do an example where we're going to see why you would rather look at C prime as opposed to the original difference. But that's where the name kind of comes from. And of course, we can apply this in general. Right? So if I have f of x is some function, then it means f prime of x is the marginal function. Right? It's just that when you use the phrase marginal, it tells you about the context in which you're thinking of the derivative. It's in an economics context. And you're thinking of it as a way to approximate what's happening when you push the margins a little bit further. So in other words, if c of x is your cost, then c prime of x is going to be your marginal cost. If you have r of x is your revenue, then if you take the derivative, r prime of x is your marginal revenue, etc. If p of x is profit, so these are some typical economic functions, then p prime is going to be your marginal profit. And again, in this context, when you see like marginal profit, like what are you talking about? It's just a way to talk about the derivative whenever they put the word marginal. It just means derivative, essentially. But it means you're thinking of the derivative in a very special way. You're thinking of it as an approximation of this sort of quantity. And when you're thinking of the derivative in this particular way, you call the derivative function a marginal function. So that's what a marginal function is. Now, because the problems here will often deal with economic type functions, it's more of an application of derivatives to economics, even though technically you can apply this idea to something else. But when you use the word marginal, it's pretty much always in economics. So it's going to be important for us to know about some economic functions. Right, so the typical ones, and we're not going to go as deep into them as you would in an economics class, but you should know a little bit about them. So we have, say, c of x is a typical for the cost function. Now, when it comes to cost, that is a very individual, context-specific thing. And it's not something that you can just sit at a table and with a pencil and paper kind of figure out mathematically. That's something that requires research, requires to actually know about the situation. So you should know that this guy is going to be just given. I'm going to tell you the cost function. Right? I'm going to tell you, here's a function that measures your cost, because you can't really figure it out, right? What is the cost? Well, then it depends on how much it costs you to rent the facility that you're running your business from. That depends on location. I don't know where you're renting from. I don't know how many people you're hiring, what it's going to cost to buy the machinery that you might need, right? It's a very individual thing. From one business to another, that function can be drastically different, totally different, and it's really something that individually you have to do actual real-world research to figure out a function that can track this. So in a math class, you're not going to be able to do that, so I'm going to tell you what this is, right? So whenever there's a cost function coming up, I'm going to just tell you, this is the cost function. I'm going to give it to you, okay? I won't always give you all the functions, but the cost function is one thing that I'm just going to give it to you. Now, another kind of function is the revenue function. Now this one is not always given. This one, though, you can actually compute based on information that you might have. So the revenue, in general, how you want to think of it, is going to be, say, the price per item or service times the number of items sold. So that's your revenue. This is the amount of money you make. Important thing here is you ignore cost. You ignore the cost of actually making that money. So it's straight up, how much money am I making by performing this business? So I open up a hot dog stand, I sell hot dogs for $2 a piece. I sold 5 hot dogs, my revenue is $10, right? So the price per item, $2 per 5 hot dogs. 2 times 5 is 10. My revenue is $10. Now, don't worry about what it cost me to buy the ingredients to make the hot dogs. irrelevant. I'm ignoring that when I'm talking about revenue. Revenue is strictly what is the money I bring in from actually doing my business. Okay. Another thing is P of X. This is the profit function. Now profit, this is the amount of money you make after your costs are factored in. So the profit function is also something that can be computed from previously known data. It's going to be the revenue minus the cost. Right? So I'm selling hot dogs $2 a piece, but maybe to buy the ingredients it cost me $1 per hot dog. So I would have made $10 by selling 5 of them, but it actually cost me $5 to make that. So my profit is actually just $5. I made $10, but really the amount of money I made after I factor in the cost was $5. That's what I get to take home, right? Ignoring taxes or whatever. So this is the amount of money made after costs are paid. So costs meaning what you have to pay to buy items, what you have to pay for salary, what you have to pay for rent, what you have to pay in taxes, blah, blah, blah. Everything that's gonna cost you money, once you take all the money you made, subtract what all the costs that go into running your business, you are left over with what's called a profit. And hopefully your profit is a positive number, because if it's a negative number, it means you're losing money. Another kind of function, so there's something called do it over here. So those are the main ones. There are a couple ones that are, so most people would have heard of those before. The next two you probably would have only heard if you actually took an economics class, but I'm just gonna tell you very short, concisely what they are. There's something called a demand function. Okay, so we might call this d of x, or we might call this little p. And this is basically going to be, so this is the demand function. So the demand function is also going to be given, because that is also something that you won't know unless you actually go out in the real world and do research. You can't actually mathematically derive this function, right? So this is again given because it describes the price at which consumers, price per item, at which consumers will consume X items, right? So this is telling you your price as a function, right? So it's very different from if you're just straight up doing, you know what, I'm selling my hot dogs for $2, that's the price, right? Sometimes you have to be a little bit more sophisticated than that. Your price needs to vary depending on what market you're looking at. And how you do that is with a demand function. So what businesses would do is track the price of the items per the number of items sold in a certain market. And if you want to find the best price for you to sell an item, what you might do is you might, at different locations, sell your items at slightly different prices. So you want to know how many items will consumers buy at a certain price. Then using that, you can actually create this function. And then using that, you can figure out what is the optimal price to get the most revenue and the most profit. Now, the demand functions normally decrease, right? So a demand function will normally tend to go down. So this is a demand function here. Right? And that should intuitively make a lot of sense. The more expensive something is, as price increases, the less of that thing people will buy. You have more people buying Toyotas than you have buying Ferraris, because Ferraris are very expensive. Not a lot of people can afford that. So if you have, your price is super high, there will be relatively few number of those items sold, versus if your price is very low, a lot of them will be sold. Now, of course, you don't just want to sell a lot of things, because if you're selling at a small price, then you're not going to make a lot of money. But at the same time, you don't want your price to be too expensive, because even if you can make a lot of money by selling one, it's probably going to be really hard to sell that one. So you kind of want to choose your price wisely. But a demand function is what you would get from research. I know that if I sell it at $20, that, you know what, 15 people would buy from me. Whereas if I sold it at $18, then I realized that 24 people would buy it from me. Is it better to sell it at $18, or is it better to sell it at $20? Might be a question that you'd want to ask. And what would you do in general? Well, you find the revenue. 20 times 15, compare that to 18 times 24. In general, whichever one gives you the larger number is going to be the better choice. In general, of course, life gets more complicated than that. But that's kind of the idea. So that would be a demand function. You're just tracking the price versus the number of things you're selling at a certain price. There is also something called a supply function. This is X. It's called the supply function. Now, it's essentially the same thing as a demand function, but it comes from the perspective of the producer or the supplier as opposed to the consumer. So again, this is tend to be given, and it describes the price per item at which suppliers are willing to produce items. Now, a supply function actually has the opposite relationship to a demand function in terms of increasing and decreasing. Supply functions tend to increase with price, right? It turns out the more money I can sell something for, the more of that thing I'd be willing to actually make, versus the less I can sell something for, I'm not really motivated to actually make a lot of things like that. So, hey Jhevon, I want you to make an iPhone for me, I'll give you $20 for it. I got stuff, I got kids, I got a basketball practice, and I'll give you $1,000 for each iPhone. I can make 100 of them by next week, right? Like if you are gonna pay me a lot of money, I'm gonna want to make a lot of things, because then I get to make a lot of money. So the supply function will tend to rise. As price rises, people are willing to make more of that thing. Now, of course, the sweet spot is when both of these actually collide. So you can, in general, plot both of these on the same thing. You can plot demand, supply. You can plot supply versus demand. And that point here is the nice thing. That point here, this is called market equilibrium. So that's like the perfect price. That is the price at which, if you set it to that price, people will be willing to buy exactly how much a supplier is willing to supply. Now, if you're not at that point, it's bad news. Because if you're before that point, what it means is that the supply is less than the demand. More people want this product than there are actually products in the market. There is scarcity. Beyond that, you have an excess of supply and less demand. So we have all these products sitting in our warehouses, but no one's buying them, right? The sweet spot is going to be here. Find the price where we're willing to make that many, and people are actually willing to buy exactly that many, right? So a lot of times you want to check your price so that it lines up with this, but at the same time, you also want to do it so that your revenue gets the most it can be, and ultimately your profit is the most it can be. Okay. So in terms of those ideas, we're not going to go too much into those. Our goal for the class is just to examine all this in terms of marginal functions, meaning, assuming we kind of know how things are right now, what would happen if we were to push the margins a little bit, right? But this is the context in which we're doing it. And so the question is, I know what we're doing right now. I know what it's costing me to produce things right now. I know what my revenue is. right now, I know what my profit is right now. If I were to produce one more item, if I were just to push that margin a little bit more, does that make life better or worse for me, right? That's the question that we are going to answer with marginal functions. And because they're word functions and I'm too lazy to write them out, I did a handout with all this stuff. So, and goes up.
Thanks.
Does everyone have them? Okay, so the first page pretty much goes over a lot of things I've been ranting about for the last 30 minutes or so. Alright, so I kind of told you, oh, we did the derivative, we did this approximation, and then blah. Then the marginal function just is basically another name for derivative. Right, so I explained that, and I explained the kinds of questions that we can answer with marginal functions. So that's the first page. Okay? Pretty much going over, well, the first page doesn't include any of this, but I just want to give you some context here. So the second page is the important part, because that kind of tells you the kinds of examples that I'd expect you to be able to do. Although problem 1 is probably a little bit easier than a question that I would ordinarily ask, but just to get you used to applying these ideas, and just to see the usefulness of a marginal function, I thought we could do example 1 first. So we'll do example 1, but example 2 is probably a better indicator of the level of difficulty at which I'd expect you to be able to do one of these problems. So we're going to focus up, try to get things back into the applied calculus swing of things. And example 1. So, example 1. So, the cost of producing X glow-in-the-dark boxer shorts. Okay, so we're given the cost function, like I said, 2x squared plus 3x. Now, yes, in general, a cost function is going to be way more complicated than this, but the idea is what's important. So, just say your cost function is like a quadratic or whatever. A. So, first I want to know additional cost to raise production level from 10 to 11. And B, what is the marginal cost? And x equals 10. And so we're going to answer those two questions. All right, let's do the first one. Additional cost, go from 10 to 11. What is that asking? Yeah?
You should plug in 11, plug in 10, find the difference.
Right. So, so that I can find C of 11. That's going to be 2 times 11 squared plus 3 times 11. That's going to be 2 times 1, 21. Plus 3, 33, 2, 42, plus 33, 2, 75. And if I can find, so this is cost to make 11. Now I look at C of 10, it's going to be cost to make 10. It's going to be 200 plus 3, 230. means the additional cost from 10 to 11, well, that's just equal to C of 11 minus C of 10. 275 minus 230, 45, right? So, if I've made 10 of these boxer shorts, how much is it gonna cost me to make one more? $45. Very, very expensive boxer shorts. How much would it have cost me to make the very first one? Well, $5 according to this model. By the time I'm producing 11, now costs are up to $45 for whatever reason. Whatever reason went into this cost function. You have to buy more equipment, hire more people. It's costing me more per boxer shorts now than it did in the beginning. Okay, so we go to B. What is the marginal cost when x equals 10? What is that asking for? Yeah.
Derivative of the cost.
So this is the derivative of the cost at x equals 10. Okay, so the derivative is
4%.
so this means I want C prime of 10. And you'll notice that that is 43. Okay, so now a couple things I want you to appreciate from this example here, which in general is going to be easier than what you'll have to do, but it's a nice exploratory example. First of all, look at all the calculations I had to go through to calculate the exact additional cost versus what I had to go through to do the approximate additional cost. I'd rather do this than doing all of this. That's the first thing. So using the derivative got me somewhere a lot quicker. Second of all, notice that the difference between these two answers isn't actually that much. The derivative approximation for the additional cost was just off by 2. And that's just at a production level of 10. 1 is not close to 0 when you consider 10 as what you're doing, right? An approximation like this will get better as x gets larger, x 1,000, 10,000, 100,000 items. Then you'll actually get closer percentage-wise. Here we're actually just off by 3-4%, and I'm willing to be off by 3-4% for a quicker, easier calculation because, of course, in the real world, you can't exactly calculate cost anyway, right? Stuff happens that you never anticipated. And so this $45 isn't exactly what it's going to cost you anyway. It is also, in the real world, an approximation. So why not just do an approximation quicker, right? Less work, less complications. So that's just in general why a marginal function might be important. So in economics, we use marginal functions because it's easier to keep track of them than the original function that we were looking at anyway. And they allow us to actually anticipate what will happen at the margin better, right? So what I can do is I can use these numbers, either one of these, to kind of say whether or not we should keep going, whether or not we should push the margins. For sure, if I'm selling each box of shorts for less than $43, then it's not worth making any more because we're definitely going to lose money, right? So that's something that you would want to interpret. So that was example 1. Example 2 is a little bit more involved, so let's actually try to work through that one together. And then let me know if you have any questions. So in example 2, so in example 2, we're given a demand function, which means the price isn't fixed. So we're told a demand function. And it's 25 over radical x. Right? So x is the number of things that I want to sell. P tells me this is the price that you should charge if you want to sell x of these things. So if x equals 1, you'll know that p equals 25, which basically means if you're set the price at $25, you're pretty much only gonna sell one of these guys. Versus, let's say X is 100, then your P would equal 2.5, which means if you wanna sell 100 of them, you should set the price at $2.50. So this is just a function that's telling you how to set your prices and what you can expect to sell at each price. So that's your demand function. So now, A asks, or we want to know, what is the marginal revenue? B, we want to know marginal revenue when X equals 100. C. So in C, we have some additional information given, cost. So another quadratic, very simplified situation. And we want to find marginal profit. Then I want to find the marginal profit when we're at 100 items. Then finally, we want to answer the question, is it worth it? Is it all worth it? Is it worth it as the 100 items? Should we produce more? Should we produce less? We're going to make an interpretation of the facts. So, yeah, let's actually do that. So, this is my demand. How are we going to find revenue? Yes, we want the marginal revenue, but to find the marginal revenue, we have to first find the revenue. So revenue is equal to what?
Price per item times number of items sold.
How do we find the price? What is the price of our items here?
That function.
The demand function tells you the price. If you want to sell X items, this is going to be the price. So that is 25 over radical X times how many items? X items. If I'm selling X items, that's going to be the price at which I can sell those X items. So of course, that is going to be 25 radical X. So my revenue function is 25 radical X, which means, how do I find the marginal revenue? Just derivative. R prime of X, what's the derivative of 25 radical X? So that's our marginal revenue. Marginal revenue at 100. I believe I asked you to interpret this number as well. Interpret. So, I mean, we have the marginal revenue, so just plug in 100. R prime at 100. It's going to be 25 over 2 times radical of 100. It's 25 over 20. It's 5 over 4. So 1.25. So $1.25. How do you interpret that number? When I say the marginal revenue is $1.25, what is the interpretation? What does that mean? Yeah.
So would that be like the overall cost or not a profit, like that would be like the entire money that you're making
At what point?
at 100
So this is how you can think of it as the additional money you would make by selling the 101st item. So given the fact that you've already sold 100 of them, what would it cost you, or how much money, extra money would you bring in by selling one more? If you were to push that margin by one more, what's gonna happen? Well, you'll increase your revenue by $1.25. Now, is that good, is that bad? Well, it depends. It depends on a lot of things. We'll talk about whether it's all worth it down here. So, more information. We know that that's our cost to produce X items, right? So this is the revenue that we'll get from producing X items here, and now this is the cost to produce X items here. How do I find the marginal profit? Yeah.
Like for the interpretation, is that the price of the item after 100? It's not like the profit, right? It's not like the gain.
No, remember it's the difference. Remember what this is, we're thinking of it as approximating revenue at X plus 1 minus revenue at X, right? Or more specifically, the revenue by making the 101st minus the revenue of making the 100th. So this is how much money I made at the 100th item. This is how much money I made from the 101 items. The actual additional difference, the additional revenue that I would pull in by making that one more is $1.25. How do we find marginal profit?
The revenue function minus the cost function.
That would give us what?
Oh, that would just give you regular profit, so.
That would give you regular profit. So profit function is going to be revenue function minus the cost function. Revenue function is?
25 times the square root of x.
And cost is given here. So this means my profit function
Is this root of
is this, which means marginal profit. Let me find marginal. Take it there. This is marginal profit. It's the marginal profit function. So marginal profit at X equals 100. Well, that would just be P prime at 100. So that is going to be, well, 1.25 minus 202. That's going to be a lot. That's going to be minus $2. $2 minus $1.25 is 75 cents. 275 cents minus 200 cents. So how would you interpret that number? Right, we would lose $275 by producing one more item. Or selling, let's say, selling one more after we've sold 100. So is it worth it? It's not about the money. I'm going to do this because it's the right thing. No, it's not worth it. No, not worth it. Right? In fact, it's probably hasn't been worth it for a while. Right? If you're at a point where you're losing $200 on a product, you've probably been losing on that for a while. So that's how it kind of tells you. So one thing you can do as a business, if you, especially you want to know if you're staying afloat, is just keep abreast of the marginal profit function. Know what that guy is, and the moment that guy dips to negative, you know something is off. You got to do something to change that. But until that, you're probably going to push the margins just enough to just kind of, to the point where you're not milking any more profit, where it's literally the profit is approaching zero. All right, we've done enough. Maybe we should do something else at this point. But let's not push the margins any further. So we'll stop there. Now next time, we're going to do another kind of applications type topic, exponential growth and decay. We'll have handouts for that too. So I'll give you guys that. You can read these up for Friday, and we'll go through them on Friday.